Assalamu alaikum everyone. Welcome to my YouTube channel, The A Square, a complete learning sphere. Today we are here to learn a very important tip, a very important trick for all those students who are unable to solve in their maths paper 1 questions. That is how to simplify square roots. Square root, basically we need to identify what is the sign of a square root. It's simply just like a division sign, but there is no number written on the outside. This is also known as radical form. Now, before we move further, I've written some numbers on the right side with a square on it. This means these are known as perfect squares. I am here to find out the perfect squares. What are the perfect square numbers? Where one square, what do you mean by one square? One square means you have to multiply 1 by 1 number with itself. Answer is 1. Then 2 square means you are multiplying 2 by 2. The answer is 4. Then again 3 multiplied by 3. The answer is 9. And then 4 multiplied by 4. The answer is 16. And so on and so forth. It will be 25. This will be 36. This will be 49. This will be 81. This will be 90. 9 and the 8. Sorry, my bad. 8 is the 64 first. Then 9 and the 81. 9 and the 81. Then 10 10 the 100. These numbers mentioned on the right side, 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. These are known as perfect squares. Perfect square numbers are those numbers which we can calculate their square root of. The square root can be easily calculated. It will be without a decimal number. Now, what if a number is written as square root 81? We know that 9 multiplied by 9 is 81. If 9 multiplied by 9 is 81, I'm writing over here as 9 multiplied by 9 as 81, or known as 9 square. We usually know that square and square root cancels out easily. I'm cancelling square with a square root. The final answer is 9. Now that's the most easiest one, because we know 9 multiplied by 9 is 81. If I do not know that whether it's a perfect square or not, I can calculate square root 81 with the use of an LCM or prime factorization. What is known as prime factorization? Prime factorization means we will be using prime numbers in order to calculate the square root of 81. I'm taking an LCM of 81. Where? Does 81 comes in a table of 2? Nope, it comes in a table of 3. I'm writing 3 27s are 81. Then 3 9s are 27. Then 3 3s are 9. Then 3 1s are 3. After that, I am making pair of two same numbers, because square means 2. Square means 2. So I am making pair of two same numbers. There it is, 3 and another pair of 3. Now I'm multiplying both 3 and 3. The final answer comes as 9, which is the final answer as mentioned above. That's your square root. Now, moving further, what if the square root, I want to identify the square root of let's say 144. Now, most of the people knows that what is 144, what is a perfect square for 144. Basically 144 itself is a perfect square, in which two numbers are multiplied with each other, known as it will become 144. Whether I use the simple term that I have been using previously, or I'll use the LCM term, I am explaining it with both the examples. Now 144 is 12 square, or I'm writing it as 12 multiplied by 12. Now 12 square means I'm writing it like this. Then square and square root are cancels out. Then final answer I'll get is 12. Now moving further, what if I want to calculate square root of 144 using an LCM? I'm taking an LCM starting from with 272, then 236, 218, 2 9, then 3 3s, then 3 1s. After that, I am making pairs of two same numbers. Now a pair of 2, again a pair of 2, then again a pair of 3. Now I'm writing their pairs outside the brackets. The final answer becomes 2 multiplied by 2 by 3, 4 3s are 12. That's your answer. Either use the above example to simplify it or use the LCM term. Now, we calculated the square root of the perfect square numbers. What if a number written over here is not a perfect square? Let's say square root of 125. We cannot calculate the square root of 125 until unless we can take an LCM. Now I'm taking an LCM again of 125. Let's see what I'll get. 125 comes in a table of 5. 5 25s are 125, then 5, I don't think so. 5 2s are 10, 5 5 25, that's correct. 5 5s are 25, and then 5 1s are 5. Now I'm getting three same numbers, those are known as 3 5 numbers. Now I'm making the pairs of 5 now. 5 and 5 are same, that it means that a pair of 5 can be easily written, but this does not have any pair. Now how to write this in a radical form? I'm explaining it like distributing it into different forms. This means 25 multiplied by square root of 5, cos 25 multiplied by 5 is 125, and square root of 25 is 5, which is I have already calculated, and 5 under root 5 is your answer. Next, moving further, what if you have a square root of minus square root 100? Minus is outside the square root. If there is a square root minus 100, according to O-level mathematics, we simply write down that it is known as a complex number, or we cannot calculate it easily because it's not in the syllabus for maths 4024. What if the negative sign is outside the square root? It simply doesn't matter whether the sign is outside, the outside sign is a positive sign or a negative sign. We simply calculate the square root of 100. Now square root of 100 is what? I'm writing square root of 100 as 10 multiplied by 10 or minus 10 square. Square and square root are cancels out. Final answer you'll get is minus 10. Now adding to this, what if minus 100 is required to be calculated apart from those students who are studying maths 4024? Now I am breaking minus 100 into 100 square root multiplied by under root minus 1. For those students who know what under root minus 1 is, under root minus 1 is known as an imaginary number, or we consider it as I or iota. Now, under root 100 we have already calculated. Under root 100 is 10. Simple final answer for minus under root 100 is 10 iota. I believe this might have clarified your concept regarding how to calculate the square root. Thank you so much.